We'll try and burn through the start of this because I know most of you are pretty across most of these concepts. But before we go into it, did I update this? No, I didn't. Sorry, I forgot to update that slide. What's continuous integration? We talk about CI pipelines a lot, but what's kind of more formal definition for continuous integration? Anyone else? Please. Yeah. Are you nominating someone?
No, sorry. It's automated tooling code and check for control errors. So if you get text file errors, and please download all of them.
Yes, I think everything you said is correct.
Maybe not formal.
But it's not continuous integration. Like it's all, like that's part of what CI involves. But does anyone know what it's about? It's more of a philosophy than a practice. Cool. Ignore that slide. Okay, so continuous integration. It's software developed. Sorry, it is a practice, but it's this idea that you continuously integrate. Right, members of a team integrate their work frequently. Usually, each person integrates at least daily. I don't know about that. Ideally, you contribute code to your master branch at least once a week, leading to multiple integrations per day. Each integration is verified by an automated build, including tests to detect integration errors as quickly as possible. Martin Fowler, super cool guy, wrote the book on design patterns and also has a lot to say on microservices and software architecture. But the key thing here is continuous integration is your merge request, your code reviews. Like it doesn't have to be a CI pipeline. It's just the idea that you continuously contribute code and we do these little short iteration cycles. I was talking to the SENG3011 students last week about this, waterfall versus agile, right? You don't do all the requirements and all the design and then do this big design up front and waterfall process. Instead, we do little short cycles and contribute regularly. Again, that's really useful because our feedback is positive, immediate and certain, right? Like you get a nice dopamine boost every time you merge into master. But it also means there's less risk per individual change. And that's really what continuous integration is all about, is helping minimize risk by automating processes and also making them nice and short. Now, when we integrate software, we do it at a bunch of different levels. So that might include making sure that your code works with other parts of the code by running integration tests locally. Then when you push to an environment, there might be some more tests that run, like often there'll be like a post-deploy test job, which your code will be deployed and then they'll run some more tests just to double check everything works seamlessly together. Or they'll run end-to-end tests where they check entire flows that involve everything from make a call to this microservice and then include every part of your choreography or orchestration. We'll talk about that either next week or maybe the week after when we talk about microservice testing. That'll be useful for Sprint 2. But this is all forms part of your continuous integration. We always want the software in a working state. We always should be able to deploy. That's not necessarily, sorry, I'll start again. That's not necessarily saying that we do deploy all the time. It's just saying that we always have a stable source of truth, a green passing pipeline on master, and we can continuously contribute to that. We develop, change, build, test, integrate, test, deliver. And again, that's our DevOps, infinity symbol cycle all over again. As I said before, integration is continuous rather than delayed. The other thing about CI, in the old days, and I'll talk about this with continuous delivery in a second, is that you get a lot of processes which were, what we call click ops, or just go click, 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 and you have people whose entire job is just like doing the same thing over and over and over again. And you get that a lot with like QA testers in software companies. So the idea of CI is to automate all of that and say, well, okay, everything should be reproducible, and everything, if not, like most things will be automated. Most CI practices aren't entirely automated in the sense that you will run your own manual usability tests, your acceptance tests, your QA demos to make sure that your software is working. that forms part of continuous integration as well, right? Because we're all just like checking that our software works. The other part of it being reproducible links back to containers, right? You want to be able to make sure that your code is the exact same as what's running in someone else's environment, and it's the same as what's running on your CI pipelines. That's a big part of reproducibility, and containers help us with that. Okay, so CI, again, this is a philosophy, but everything Will said about automated building, testing, merging regularly, they all form part of continuous integration practice. So version control with Git, build processes with Maven, Gradle, CMake for C++, Cargo for Rust, Yarn for JavaScript, automated testing. That can include both front-end and back-end tests. So like, you've got your JUnit and PyTest that you're all familiar with, but then also things like Selenium, which allows you to test out workflows on a user interface and make sure that they work as expected, and that's all automated. Check out Selenium because it's pretty cool. And then things like team processes are also included in CI. That's like your code reviews. That's your PR cycles, and keeping things nice and short, keeping PR cycles nice and short so that you have small PRs that get checked in regularly, as opposed to what I've seen heap, which is massive 30 file change PRs that get merged in, and lo and behold, they break stuff. And then you obviously need some infrastructure to automate processes, and that will give you your CI server. Obviously, you've been working with the runners on GitLab for several years. You'll be using GitHub Actions as part of your project. Here's an example of a more complex CI workflow. I'm not going to talk through it because we're low on time. That brings us to continuous delivery, which is a software development discipline where you can build software in such a way that the software can be released to production at any time. And this is a big thing. Again, I was telling the SENG 2021 students last week, the biggest problem for software companies is time to market. It's the time between we've got this great idea that we want to build, the kind of conception and ideation that you guys are doing at the moment for your project, and let's actually have something out in the real world. And that often takes months and unfortunately years. And the market's moved on, the requirements evolve. So continuous delivery is all about let's have a product that's always ready to go. And at any time we can push a button and push out everything to customers. Oh no, I have the same slide twice. That's bad. Okay. There is a big part of this. Sorry, did I miss? No, okay. A big part of this is automating delivery processes, and that's things like your deployment process. So having it so that instead of including a series of manual steps where a person has to do this and then this and then this to deploy the software, and they can just say, push a button, and then it's all out, and customers are using it. That brings us to continuous deployment, which is actually, sorry, I'll go back. Who knows the difference between continuous delivery and continuous deployment? Anyone? Nope, okay. Continuous deployment is where it's the same as continuous delivery, except for one thing. That release process is automated. So rather than saying, okay, well, everything's automated except for a single button push, which allows you to release software to customers, continuous deployment just says, just release it. As soon as it's merged into master, it gets rolled out, customers are using it. And aims to automate the release of every working version of software to the production environment. What do you think some of the trade-offs are of these two? Because you could pick one or the other, right? In any setting. Yes. Yeah, that's a really good point. So there's more risk in the sense that if you make a bad change, you don't have anyone sort of sitting there, waiting to pull the trigger. That you can say, no, wait, let's delay this release. It just gets rolled out automatically. Yep. Hmm.
But it's like a minor change kind of like packaged set of changes.
Yep.
But then it continues a bunch of little details or whatever.
Yeah. Yeah, spot on. Does anyone know what the term change boarding refers to? So change boarding is, I don't know if it's a real word actually, but it's about onboarding people to changes. And like you've said, the downside of continuous deployment is that if you are, you're constantly writing new features and you just roll them out to customers, then customers are constantly bombarded with, oh, here's this new feature, here's this other new feature, here's this other new feature. And that's kind of annoying, right? Like, every time Facebook Messenger updates, I always get a massive headache. I don't know why. It's just like your brain's used to like looking at a certain layout. Anyway, but so change boarding is a general thing in product management where you have to sort of walk your customers through the changes that have happened. But when it comes to releasing, it's this trade-off of, well, we could release less frequently, but then if we do that, we have to release more at a time, right? Because we've done all these features in a certain time. And you get products that like will release every month or they'll release every year. But then if we release everything at once, right, we're going back to waterfall land where we take on all this risk because we've got all these things that are going out to production at once. So again, that's a trade-off, something to think about. Are there any others? Yep. Yeah, for sure. Like you have to set up the infrastructure. I wouldn't say like between continuous delivery and continuous deployment, there's a huge amount of difference in that respect. But certainly, like in general, like it's a you pay some extra cost now to save you in the long run. Sorry, you first. Yes. Yeah, and that's I mean, this is a CI thing, but that's annoying, right? Where it takes an hour for the CI to run, and that delays your development process. That forms a bottleneck. Again, think of theory of constraints. That's a trade-off as well. But then it's like the alternative is like you don't run those tests, and then what if someone writes software that has a bug in it, and that those tests would have picked it up, and then you've deployed it, but then the tests were like, actually no, this is a problem, and then you have to go roll back and stuff. While I'm on that topic though, back to CI, there's cool things like you can do static analysis to say, well, what's the probability that, like, if you've got a massive monolith, again, this is why we like microservices, but if you've got a massive monolith and like, well, we don't want to have to run all 2 million tests every single time the CI runs, because that's annoying and takes ages. So what we'll do is run some static analysis and say, well, here's the files you changed. What are the other files that might have been impacted and the tests associated with those files, so that you only run part of the tests, and that brings on a certain amount of risk, right? But then you get the trade-off of saving some time. Sorry, I got distracted. Luke, you had another question. That's true. We have also, we'll go through this in a second. We've also set it up. We've set up the continuous deployment. Sorry, we've set up the continuous delivery process for you, so that you actually have to manually push your code to AWS. So we've set up continuous delivery. We're just looking at continuous deployment as another sort of similar related concept. Cool. I think we've addressed most of the stuff in the next slide. You need a strong foundation in continuous integration if you're going to do delivery or deployment. You need to be testing regularly. You need to consider these sorts of trade-offs that we've just discussed, where it's like, well, maybe it takes a long time for your CI to run, you have too many tests, and to be able to engineer solutions around that. But for both of them, you need a very strong testing culture, because it only works when you have tests that actually test the right thing, right? And then you obviously need automation. I don't know where I talked. I think I talked about ClickOps in the next slide. Yeah, you need to have everything automated. More change boarding. We talked about that. A big thing with deployment, which we'll look at either next week or maybe week 5. Chris will come and talk about feature flags. Chris is one of he's not mentoring this time, but he's mentored these courses in the past, and he works at Atlassian, and his entire job is building feature flag software. And basically, feature flags allow you to release software in a controlled manner, so that maybe you've got continuous deployment, but you've actually got your new feature switched off until you want to turn it on for customers. Very interesting, and you'll be using that in Sprint 2 as well. Here's a nice visual diagram from Atlassian showing the difference between continuous integration, delivery, and deployment. Any questions? Yeah. Oh, that's a good question. Smoke tests are just kind of like, how to describe it? I could give you I'll look it up and give you a formal definition in a second. But smoke tests are basically just like, let's run a bunch of random tests on some stuff to make sure that nothing accidentally broke. You can kind of think of it as like, the thing that comes to mind whenever I think of smoke tests is like, you know, when the police come in and then they put gas everywhere and they go get their guns out and stuff. Not super related, but you're kind of just like throwing smoke at stuff just to see if anything breaks. Yeah. Yep. That sounds like a good definition. Yeah. No. It's more of just like a sanity check to make sure that you didn't accidentally break everything when you deployed. Cool. Okay, the next part of this lecture relates directly to your projects. So infrastructure as code. Now this is where I get to talk about ClickOps. So I said before that you often have had lots of people in companies, and their entire job is just to go click, click, click. You know, in AWS, you'll start to see you can actually create Lambdas and EC2 and ECS instances yourself just with a few clicks. We don't want you to do that because that's fine, you know, if you're one person working on a small project, but it's not very scalable when you start to have big teams and big companies. So infrastructure as code is the managing and provisioning of infrastructure through code instead of manual processes. It codifies all of your people who do those jobs and just go click, click, click all day and puts that into a file. It saves time and cost. You're not paying people just to sit there and do the job of a robot. It's more portable because I think I mentioned this last week, you can get your infrastructure as code and then put that in a repo, and then someone else can do that and run the exact same process as you have and create the same resources in AWS. It's more scalable because you can just add resources as you go and you're not adding to a manual process. Now, the thing with cloud computing is some people say, oh, you know, cloud computing will solve all our problems, right? Like we don't have to worry about ClickOps anymore because cloud computing, and they use this sort of buzzword that like is the golden solution. But the reality is, like, even if you're using AWS for infrastructure as a service or platform as a service, you still need to do configuration, right? You still need to say, I want these resources, I want this amount of memory, I want it for this amount of time. And so that's what our infrastructure as code is configuring. It's our resources on any platform. Cool. Okay, next one. Actually, the last thing I had to say on this is that you might have seen other sort of infrastructure code before, like Python and shell scripts. We use them heaps in CSE courses just to do things like create your Jira boards and give you permissions for Confluence and stuff. So they're more sort of imperative, they're imperative languages, whereas Terraform, which we're going to talk about in a second, is more declarative and it's more built for this kind of stuff. So Terraform is an infrastructure as code tool that allows a user to define resources in a human-readable configuration file. It's super powerful. We'll be using it for AWS in this course, but you can also, I've used it in the past for things like building dashboards. You can use it for pretty much anything that requires any sort of configuration. It's declarative, so more like SQL and Haskell in that sense. And there are 3 stages. There's write, which is where you write your code and define the resources. Then plan, where you execute a command called Terraform plan. And that what it does is says, okay, here's all the resources I'm going to create, and it gives you essentially just a plan of what it's going to do. And then apply actually makes those changes and says, okay, I've just created these resources in AWS or whatever it's doing. Let's look at our Terraform code. Okay, so I sent you some instructions this morning about how to access GitHub and this teaching space. Sign on. Please do that. This is where you'll be putting your code, and this is where you'll be doing all your work for the project. You'll need to start by forking this repo, which is called the template. And what it contains is a bunch of stuff, including a CI pipeline and some Terraform. So let's look at the deployment. folder. And we'll look at lambda hello world.tf. Okay, I've got 8 minutes. Let's go through this. So very, very quickly, I'm not going to go through the syntax. You can just figure that out. It's not too difficult. We've given you all this code, and a lot of your configuration, if you're just building basic stuff, will be tweaking the files we've given you and copying and pasting stuff, so you don't have to build it all from scratch. What this does is it essentially says, here's a resource, and here's where the resource lives, which is just in the repo in this hello world handler.py. So this is all our hello world lambda includes. It's just like a simple function. Oh, yeah, sure, sorry. There we go. So this creates a resource. This specifies where the resource is coming from. This zips up your Python code so that it can be uploaded to AWS. This one creates the actual Lambda in AWS. They create a Lambda function. Again, this is things like with the role. So IAM stands for Identity Access Management. So you have just been given IAM user access to the AWS environment that we run. So you'll now be able to create these Lambdas. I'll talk about how this works properly in a second, though. So you create the Lambda. This next one gives permissions for it to be run. You can see that it's connected to an API gateway, because remember we talked about last week, you've got a series of Lambdas, you need to unite them all under an API gateway so that someone can actually call them. This next thing is called an integration, which is kind of just like a bridge between, you've given it the permissions, but you still need to create a sort of bridge between your Lambda and the gateway itself. Then the next one is the route, which you can just think of as being the physical route, where it's like, slash mo9a hello world or mo9a alpha. And then the last one is a CloudWatch log group, which is essentially just a thing where you can see all the logs from that Lambda. That creates the resources for you. A lot of this we've even given you lovely to-dos where you can say, here's the stuff you need to change. If you have questions on it, firstly look at documentation, because there's heaps of Terraform documentation, lots of AWS documentation. And then if you're still stuck, post on the forum. Webster, who has put all this together and has done an absolutely amazing job, will be there and he'll help you out. And this is, as I said, the first time we're running it. So we're going to do a lot of learning with you, which is really exciting. Now, very quickly, I'm just going to run through the pipelines. So a lot of your interaction with AWS won't be direct, because what you'll do when you want to create resources in AWS is that if we look at this terraform.yaml, you'll see that there's a manual process which is called deploy to AWS, and you can say which environment. For sprint 1, you'll just be deploying to dev, and then for sprint 2, you'll do staging and production. But what this YAML file does is it specifies a CI pipeline which actually piggybacks off another CI pipeline, which we will look at now. That's in this repo. And what that pipeline does is, firstly, again, you say which environment you're deploying to, and then takes in some inputs. Where are we? Okay, it sets the group name. So this is important. Make sure you have your group name correctly specified in your repo, because what that will do is it will attach whatever Lambda or container you're building. It will make sure that your group name is prefixed to that, so that your if you make a resource with the same name as someone else, then those two don't mix up namespaces. The next thing the pipeline does is inject secrets into the environment. So instead of having a bunch of like passwords or secrets in plain text, in this GitHub organization, there are a bunch of secrets. I'll actually show you. I go settings. The only person who can access those is me. So if you need to access secrets for whatever reason, where are we? Yeah, actions. So these are our secrets that are accessible via the pipeline. But if you need to do stuff with secrets for whatever reason, just post on the forum, and I can help you out there. So it injects the secrets into the pipeline so that we can actually access AWS. And then creates a new Terraform instance. It runs Terraform format that just does, I assume, formatting on your Terraform code. It runs Terraform plan, then it runs Terraform apply, actually creates the resources, and then it gives you an output. Let's see that in action. If we go to actions, which is how you invoke these pipelines. Sorry, wrong one. Go to actions, deploy to AWS, and then let's go Terraform deployment. Here we go. Cool. So set up Terraform. That will run this. I think just downloads Terraform into the CI environment. This sets the group name. This does the secrets. The interesting stuff is when we get to Terraform plan, and this actually says, here's all the resources that I'm going to create for you in AWS. Here's our CloudWatch. Here's our IAM policy. This will do it for all of the resources, not just your hello world. So everything like the S3 list that we've got defined in that repo will get created. So it says blah, 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 refreshing state. Now, because I think how this has worked is Webster's run the pipeline before, and so he's created the configuration, and now he's running it again. So when we run Terraform plan, it says, well, you're not making any changes. So what it'll do is it'll look at the current Terraform state and then say, what changes are you making to that state? Similarly, when we run apply, it will just actually make those changes and then say, well, your infrastructure already matches the configuration, so there are no changes. Actually, I've only got 2 minutes. Okay. Very, very quickly, you can also look at these Confluence documents. This provides more information on the auth infrastructure, but for this one, this is the instruction on how to deploy your services. And this is our nice diagram on how that all works. So again, you've got your source code, you've got your HCL, which is your Terraform group name. Secrets get injected. That does your Terraform plan. Terraform apply deploys the service. And then we also have the Terraform state, which is, again, the current state of the AWS resources sitting in an S3 bucket. Now, important to note, you aren't yourselves running these commands. These are run by the pipeline, which is its own user on AWS. I think it's called SENG3011 executor or something like that. So most of your interaction with AWS when it comes to creating resources will be through that. But you can actually go onto the console and say, okay, I've run this pipeline. Now I can actually see my resource in the console. That's useful. And you can also probably tweak stuff around. We'll give you access as you need it. So if you need access, just please post on the forum, because at the moment you guys have nothing. We'll give you a few baseline privileges, but after that you just need to come to us and we'll determine whether or not you can get that access. Any questions? No? Awesome. Have a cup of tea, have lunch, 2 p.m. That's everything I had to say on CI and CD. Good luck, and we'll talk next week. We've got some more guest lectures coming in, which is super exciting. Thanks, everyone. Thank you, online people. Have a good week.